Hi, welcome to the Introduction to Hypothesis Testing video lecture. We're also doing the z-test in this one. As I mentioned before, this lesson is really important one. So if you have any questions, please let's get those addressed before we go on. Alright, so we'll start off with a question that we might want to answer. Suppose we've got a sample of 50 pizza deliveries of a company that claims to deliver in under 30 minutes on average. If the sample has a mean of 28 minutes, and suppose we know the population standard deviation is 5.6 minutes, can we determine that the population mean delivery time is less than 30 minutes? This is the kind of question that we're going to answer using hypothesis testing. Basically, can we conclude that the mean is less than some number, greater than some number, differs from some number, or can we not? And then later we'll get to the proportion as well. But this is exactly the kind of question we're trying to address. In every hypothesis test, there are two hypotheses. The first one is called the null hypothesis. It's null as in nothing, as in no information. It's also called H0. So the null hypothesis is the hypothesis of no information. And we'll talk more about that as we go. The other one is called the alternative hypothesis, and it's labeled HA or sometimes H1. They're interchangeable. The alternative hypothesis is what we're trying to prove. We are stuck assuming the null hypothesis unless we have sufficient evidence to conclude that the alternative hypothesis is true. So let's talk a little bit about the concept of hypothesis testing to start with. So it was actually modeled after the criminal justice philosophy that a defendant is innocent until proven guilty. So for that scenario, we have the null hypothesis, again, what we're trying to assume, which is that the person is innocent, versus what we want to prove, or what we're seeking to prove, that the person is guilty. So we have innocent, which is H0, until proven, HA. Okay, so innocent until proven guilty, H0 until prove HA. Continuing with that analogy, we have two possible conclusions. If the defendant is found guilty, then we would say, reject H0. There is sufficient evidence to conclude what HA says, which is that the defendant is guilty. So in other words, we have succeeded in proving what we're looking to prove. Otherwise, if the defendant is found innocent, keep in mind, for some of the famous cases that we've had where people have been acquitted, Casey Anthony or OJ or some of the other ones, if somebody's acquitted, it does not mean the jury is affirming the person is innocent. It just means that they don't have enough evidence to conclude that the person is guilty. Okay? Just means the prosecution has not met the burden of proof. So in that case, we'd say, fail to reject H0. There is not sufficient evidence to conclude that the defendant is guilty. And I want to emphasize here that that is very different from saying accept H0. There is sufficient evidence to conclude that the defendant is not guilty. That is different. If we are failing to reject H0, that really means that it's inconclusive. Okay, so we have an inconclusive result. We are never affirming the null hypothesis. We're never looking for proof for the null hypothesis. Okay, we either have enough evidence for the alternative hypothesis or we don't. So that's the concept. There are 4 steps of hypothesis testing, and I'm going to walk you through each one of them. First one, we have to set up the hypotheses, and I'll show you how to do each one of these. Step 2, we have to calculate something called the test statistic and the p-value. Step 3, we have to state the rejection rule. And I have to tell you what that is. Step 4, we have to state the conclusion. There's two parts of it in the words of the problem. In the case of the hypothesis test, or in case of the criminal justice analogy, the hypotheses, again, innocent versus guilty. The test statistic and the p-value are essentially the evidence. The rejection rule would be the standard of evidence. So you have to prove beyond a reasonable doubt, and the jury would have to determine that. And then state the conclusion in the words of the problem. That's the verdict. All right? Okay, so the first step, setting up the hypotheses. So the first test we're going to do is the z-test, which is analogous to the z confidence interval. We're going to be testing about mu. So we have three possible sets of hypotheses. The null hypothesis is always mu equals a specific value. The alternative could be that the population mean is less than some value, or it might be greater than some value, or it might just be not equal to some value. Okay? Some textbooks might tell you that, for example, up here, the null hypothesis would be the opposite of less than, which would be greater than or equal to. And that's okay, but usually we write that as equal to versus less than, greater than, or not equal to. It doesn't really matter anyway, since we're never concluding H naught. The two hypotheses on the left here are called one-tailed tests. So if it's less than or greater than, they call it a one-tailed test. Less than is a lower-tailed test. Greater than is an upper-tailed or a right-tailed test. And then this one is a two-tailed test because you're going to reject H naught if we think that the mean is less than or greater than the hypothesized value. So the alternative hypothesis, again, is what we're trying to prove. So what we usually do is we'll read the problem, and whatever the researcher or whoever it is trying to prove, that's what we'll put as the alternative hypothesis. So in this one, a researcher believes the mean is more than 50. That means HA is going to be mu greater than 50. And the null hypothesis is always going to be that same number. So that means the null hypothesis is going to be mu equals 50. Okay, so let's do some practice. And probably what you should do is try the example, pause the video, try the example, write down, and then see if your answers agree with mine. So in this first one, we have an economist who wants to know if the average price has decreased since 2002 when it was $530. So think about what you think those hypotheses would be, pause the video, and then check your answer. Alright, so here's the answer. We want to know if the average price has decreased. So decreased means less than. When it was 530, so we're comparing, is it less than 530 now? And of course that means that the null hypothesis is equal to. So I hope you got that right. But let's do a couple more. In this one, we have a farmer trying to decide whether to use the same brand of tomato plant next year. And we want to know, do they produce more than 20 per season? So give that one a try. So we're looking to, in that one, we're looking to prove that mu is greater than 20. The population mean exceeds 20. So the null hypothesis is going to be equals 20. We'll try one more. A criminologist interested in whether the average sentence for repeat drunk drivers has changed when it was 90 days. Try that. And this one, has it changed, means it could be less than or it could be greater than. Either one is fine. So, so that means that one's going to be not equal to. So, and of course that means that the null hypothesis is mu equals 90. All right, so I hope you're getting the hang of that. So what would be the hypotheses for our pizza delivery example? In that one, remember we had, they were claiming that they delivered in less than 30 minutes on average. So their claim is less than 30, so that means the alternative hypothesis is going to be mu less than 30. And that means the null hypothesis is going to be mu equals 30. Alright, so that's the first step, back in our list of steps. Our first step was setting up hypotheses. The next step is calculating the test statistic and then the p-value. So, the test statistic is calculated based on the data. Every hypothesis test has one. Every different kind of hypothesis test, and we'll do several of them, has a different formula for the test statistic. Here, for the z-test, our test statistic is x bar minus the hypothesized value divided by sigma over the square root of n. And if that looks familiar to you, it should, because that's from the central limit theorem. And in fact, this comes directly from that. So just for clarity's sake, I'm going to use the notation z with a star subscript. Your textbook uses z, and that's okay, but I just want to be clear. So, again, the link to the central limit theorem. So for our pizza delivery example, if we plug in our example, they had a mean of 28 minutes minus the hypothesized value, which is 30, over, we said sigma was 5.6, and our sample size was 50. If we do that calculation, we get negative 2.53. Okay. Again, notice the standard deviation is from the population. That's why we're using the z-test and not a t-test, which is we're going to do next. Okay, so that's our test statistic. The next thing we need to talk about are p-values. So what we want to do for the p-value is find how likely it is to get a sample mean as extreme as the one we got if we assume that the population mean is as hypothesized. So we need to find the probability, assuming mu equals 30, as in the null hypothesis, that the sample mean of 50 observations would be less than or equal to 28. That's the p-value. And that comes from the central limit theorem. So we want the area below negative 2.53. So we're finding the probability. So we look up negative 2.53 on the standard normal table, and we get 0.0057, and that's the p-value. So in this case, that would be the probability of getting x bar less than or equal to 28 if mu is 30. All right, I'll fix this little error here. Does a probability of 0.0057 indicate that it's unlikely? That brings us to the rejection rule. The researcher decides on a cutoff point before running the test. That's called your alpha or your level of significance. 0.05 is the most common level of significance, and that comes from the rare event rule. Okay, and I have to stop now. We'll continue in the next presentation.